Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, good afternoon, everyone.
Good afternoon, Mr.
Good afternoon, Mr.
How are you today? Fine?
Very good, sir. How about you?
Fine, thank you. Good. So if you're good, you're ready for the midterm, isn't it?
Yes, sir.
Inshallah. So please study well for the midterm. Okay. So today will be the last lesson before the midterm, and we have a couple of things that I have to explain to you. And after that, I'm going to give you a chance to ask question if we still have time. Okay. So so before that one, as usual, we pray first. Pray begin. Amen. And as usual, please fill in your attendance in the your WhatsApp group. Okay, finish. Yeah, let's start the lesson today. I'm going to wait a minute. I'm going to share my screen. And I'm sorry, I have to turn off my camera so I can write. Okay. So for today, there will be no new topic. We are still talking about the electronic configuration. Okay. So there are some additional things that I want to explain to you today regarding with the electronic configuration. It is about the exception of the electronic configuration. It's about the question that I asked you last lesson, if you remember, in Latihan 2.4, if I'm not mistaken. Maybe you can open your book in page 57, the configuration of electron of, this is the question that given is the electronic configuration of AR like this is written like this. Oh, it's too big, sorry. It's still too big. Why it is too big? Choose this one. Now it's okay. Sorry about this. Okay, so it is AR 4S2 3D. It's getting slower now. 3D 9 or AR 4S1 3D 10. Okay. The question is, which one is more stable? Yeah. Which one is more stable? This is the question. Okay. Now, please look at your periodic table. What element is this? If they have how many electrons here? 18 in argon, 20, 29. 29 electron. Which element is this? What is the name of the element? Yes?
Argon.
Yes?
Copper.
Copper? Is it copper? 29? Yes, it is copper. Good. So it's actually copper, right? Copper 29. Okay. Now the question is, which one is more stable, this one or this one? Actually, if we following the Hund's rule, we are going to write like this. AR 4s2, because 4s2 coming first, and 3d9. Yeah. Actually, we should write like this if we following the Hund's rule. Yeah, 4s2, 3d9. But when you look at this, we have to see the orbital. Now, S have one orbital, D have 5 orbital. 1, 2, 3, 4, 5. Okay. I want to distribute this electron. If this what 4s2, so how many electron? 2 electron, 1 up and 1 down. And 3d9, how many electron? 9 electrons. So up, 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 up. We have now maximum up, yeah, 5 electron, and then down, 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 down. It must be like this. But unfortunately, this electronic configuration, this kind of electronic configuration is not stable. Why it is not stable? So to understand about stability, we have to know what is stability. Yeah, in terms of course, electronic configuration. Stability is something which is stable, yeah? So it is the exact position of the electron. If it is stable, then it is exact position. In terms of stability, we have two conditions to make the electronic configuration is stable. One of them, the orbital must be half full. This is the first condition that make the electronic configuration stable. The second one, the orbitals must be full. Okay, the orbital must be full in the same subshell. Both of them must be orbital in the same subshell. Okay, now take a look at this. Now if I have this 4s2, this one, it is full or half full?
Full.
It's full, so it is stable, isn't it?
Yes, sir.
Because it is full, yeah. This condition is enough to make it stable. Now, how about this 3d9? What do you think? It is full or half full?
Not full and not half full.
Yeah, this is not full and not half full. So that's why this is actually not stable. Okay? This is not stable. But when there is a possibility to become stable, when there is a possibility to become stable, then the electronic configuration must be rearranged. Rearrange the electronic configuration. If there is a possibility to become stable, yeah, if there is possibility to become stable. Kalau ada kemungkinan ya, if there is a possibility to become stable, then you have to rearrange. Now, let's take a look at this example, whether it has the possibility to become stable or not. Let me write again. Okay, sorry. Let me write again. Copper 29, it is AR, and 4s2, 3d9, right? Let me draw again. Okay, this is like this. Sorry. Yeah. Okay. What do you think? Is there any possibility to become stable? If I can rearrange, the electron.
Yes.
Yes. How to become stable? How to rearrange the electronic configuration? This electron, the one which is in 4s2, can jump to this one. This is called as an excitation or electron jump. Excitation is electron jump. So this electron jump to here. So if this electron jump to that place, what will happen? Then we will have this kind of electronic configuration. Isn't it? Because this one electron is jumped to here. Now it is become like this. Now, take a look at this one. What do you think? According to the stability, it is stable or not now? Here.
Yes, sir.
Stable.
This
Yes. Stable.
Stable.
is half full, isn't it? This one?
Full.
Full.
Full. So both of them are stable. So that's why this electronic configuration will changing into for S2 3D, for S1 3D 10. So this is the one which is stable. This is the one which is stable. Okay, is it clear?
Yes, sir.
Okay, so this phenomena is generally happening in the electronic configuration which is ending with for example S and D. For example, for S3D or 5S or 4D, and the number of electron must be 2, 9. Okay, then if it is 2, 9, then it will become rearrangement. It is become 4S1 3D 10. If it is this one, it is become 5S1 4D 10. Yeah. So the one which is ending with 3D9 or 4D9, it will become 10, and the 4S become 1. Yeah, this is the first possibility. The second possibility also possible if it is 4S2 3D5, 3D4. 4S2 3D4. This is also can be rearranged. How it is rearranged? Now, let's take a look at the example. 4S2, if I'm drawing the orbital 1, 3D4, 1, 2, 3, 4, 5. So it is 2 electron here. This is 4 electron. 1, 2, 3, 4. As you can see, this is stable for S2, but 3D4 is not stable. But the electron can jump. This electron can jump here. Yeah. So what will happen if the electron jump? If the electron jump, now it is become, this is 1 here in 4S, and 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Now both of them will become stable now. Yeah. So for S2 3D4 will change into 4S1 3D5. So this is the most stable one. This is stable. Okay, guys, is it clear?
Inshallah, sir.
Okay. So this is the stable one also. So we have this exception, yeah, in the electronic configuration. Okay, so this one, and then after that, the last thing that I want to explain to you is the electronic configuration of ion. Electronic configuration of ion. This is the last thing. Okay. So what does it mean, electronic configuration of ions? So for example, I have sodium 11. How I can write the electronic configuration for sodium 11? 1s2, 2s2, 2p6, and
2s1.
3s1,
3s1. 1.
isn't it? Now, how
Yes.
about if I have sodium plus 1? It does not become ions. What will be the electronic configuration for this? So what happened when sodium neutral become plus 1? It is gaining electron or losing electron?
Losing electron.
Yes, it's
Losing
losing electron. How many electron is loose?
1.
1.
1.
Which electron are losing? I have many electrons in the electronic configuration here. Which electron?
3s1.
Yes, this electron will gain. This is we call as valence electron. Valence electron. What is valence electron? Electron in the last shell. Okay, electron in the last shell. As you can see from the number here, number 3 is the last shell, isn't it? 1, 2, 2 is in the shell number 1, shell number 2, shell number 2. No, now here is the shell number 3. So this electron in the last shell will move. Then sodium will losing 1 electron and it will become sodium plus 1. So that's why sodium plus 1 will have electronic configuration like this without 3s1, because sodium plus 1, it means that there is only 10 electron. Okay, is it clear? Is it clear, guys?
Yes, sir.
Okay, now how about the negative one? So for example, if I have chlorine, if I have chlorine 17, okay, how I can write the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p,
6.
huh? 3p,
6.
6. Are you sure?
5.
5.
The 17 we have, yeah?
5.
It's like this. How about now if I have chlorine minus 1 electron? What will happen? It means that 1 electron will be added, isn't it? It's chlorine
Yes.
17 in minus 1, then there will be 18 electron. So that's why you will add 1 electron. So the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6 now. Okay? Is it clear?
Yes, sir.
Okay. Okay, now let's see another things. If I have iron, can anybody check what is the electronic config? The atomic number for iron? What is the?
26.
Huh?
26.
26.
26. Okay, let's draw the electronic configuration. If I'm using this argon, yeah, argon 18. After argon, 4s, 2, 3d, 6, isn't it?
Yes.
Enggak? 4s2, 3d, 6, right? Is there any rearrangement in here? Let's take a look at the orbital. 4s2, 1. Sorry, let me write here so you will understand. 4s2 is 1, 3d, 1, 2, 3, 4, 5. 2 electron here, 1, 2, 3, 4, 5, 6. Is there any possibility it is to become a stable one?
No.
The half full, this is not stable, this is half full, but how I can make it stable? It's difficult, right? It's impossible to make it half full or full, yeah? So that's why there is no possibility of rearrangement, so the stable one is this one. If there is no possibility to rearrange, then you will not change it and it has become stable like this. Okay? So this is the stable one. Okay, now my question is, if I have iron plus 2, what will be the electronic configuration? AR?
Argon, AR, 4s2, 3d4.
Normally you will think like this, right? 4s2, 3d, 4. Isn't it? Because plus 2, it's mean that losing 2 electron. But is it true or not? Remember, when it is become ions, then here I wrote here, then the electron that will gain is the valence electron. Remember here, valence electron. Valence electron is the one in the last shell. Okay. Now take a look at again this one. So which one is the valence electron? What do you think? Which one is the valence electron? This 2 or the 6? 2 or 6? It must be
Yes.
1 valence electron. So the valence electron is this, because this is in number 4, the shell. So this is the valence electron. So that's why it is not like this. Okay. So the electronic configuration will be for iron 2 plus will be argon 18 3d 6. 4s2 is gone. Ya, yang 4s2-nya sudah hilang karena 2 elektronnya sudah menjadi plus 2. So it's remaining Ar 3d6. So this is the true electronic configuration for the iron plus 2. Okay, do you have an equation up to here? This is the last that I want to explain to you. No other things, and after this one, we will come to the question. Yeah.
Sir, tadi kenapa kok bisa valence elektronnya yang 4s2 tadi, sir?
Because it is in shell number 4. Look at this number. This is number 4. This is number 3. So this is in the shell number 4. Shell number 4 is the outermost, lebih keluar. If you compare with this 3. Okay?
Okay, sir.
So this order is according to the energy. Urutan ini berdasarkan energi kan, outbound energy. But valence electron are different. It is according to the shell. If you see the shell, 4s is actually is in the shell number 4, but 3d is in the shell number 3. So that's why this electron is in the outermost than the electron in 3d. That's why these 2 electrons that will gain. If you have A plus 3, then there will be AR18 3D 5. Duanya dari sini, 2 from 4s2 is gone, and one of the electron will be from 3D. Okay? Any other question? Yes, do you have question? I'm finished. I have finished the topic. Now it's turn to you. If you have any question regarding to the midterm, anything that you want to ask, please ask. There will be 20 questions, yeah, in the midterm. 10 question will be chapter 1. Will be coming from chapter 1. You know the chapter 1, the one that we made the unit test already. Yeah, before we study about the atom, it's about the introduction to chemistry, about matter, about the what experiment, yeah, apparatus, those kind of thing. It's 10 question, and another 10 question will be from the atoms, starting from the atom and its subatomic particle, proton, electron, neutron, and then about the history of the atoms, and then the last one is about the electronic configuration. Totally will be 20 questions. Tonight, inshallah, if I can finish it, I will give you the pointers, kisi-kisinya ya, which topic that I will ask to you. Yes, question. I'm waiting for your question. Now, I finished already my topic. So everything is okay. No question. If there's no question, we still have time. So let's continue to solve problem then.
Mister,
Yes.
can I ask the question?
Of course.
Can I use bahasa?
Yes.
Oke, Mister. Kan kalau kita belajar kan yang outbound mungkin.
Ya.
Kenapa ya, Mister? Yang didahulukan itu kan SP, SP, SP gitu.
Yes.
Kan ada yang 4S, lalu 3D yang ada tengah-tengah itu, Mister. Kenapa nggak 3D aja dulu gitu?
You mean like this? Sorry, I have to close my camera first because I couldn't write if the camera is open. Okay. You mean this? You mean this, right? Why 3D is coming first than 4P, isn't it?
Yes, it is my question.
Yes, because this is different. This is according to the energy, guys. Outbound is not according to the shell. Outbound order is according to the energy. So 3D have let's say lower energy than 4P. Lower energy than 4P. So 3D in terms of energy have lower energy than 4P. 4P is higher than 3D. That's why the order is like this. But if you asking me, how about the shell? The outermost shell is 4P, 4P lebih di luar. Yeah, this is in the outer shell than 3D. So seperti ini, shell itu tidak selalu menunjukkan bahwa energinya itu selalu lebih tinggi. No. Best thing is according to Bohr's, right? Bohr's think that if I have an atom here, so I have a plate like this. We call that one as a shell, right? Like this. and the shell will have an energy, right? But now Bohr's is not used anymore. Bohr's atomic model is not used anymore. We are using what now? The revision of Bohr's atomic model. What we use?
Ah,
What we use now?
Quantum.
Quantum,
quantum.
isn't it? So which one is quantum model? This one is the quantum model, the one which is using the orbital. So don't be confused with Bohr's. Jangan bingung dengan Bohr's. Memang kalau menurut Bohr's ini harusnya 4P ada 3D harusnya di sini ya. Ya enggak? 3D will be sorry, is actually I have to explain like this. 3D is bigger than 4P, 4S, isn't it? Harusnya 3D ini di bawah kan, di bawahnya 4S, ya kan? Harusnya, ya kan? Harusnya gini, 1S, 2S, 2P, 3S, 3P, 3D, harusnya kan? But now, it's not like that. 4S first and 3D, because 3D have higher energy than 4S. Nah, kalau kita berpikir seperti Bohr's, itu pasti kayak gitu. If we think like Bohr's, then we're going to say 1S, 2S, 2P, 3S, 3P, 3D, 4S, but it is not. It is 1S, 2S, 2P, 3S, 3P, 4S first, and then 3D. Okay, now is it clear?
Yes, sir.
Okay, any other question?
Can I ask about the valence electron?
Yes, of course.
Nah, Mister, kan misalkan ada 4 S2, 3 3D10 sama 4P2. Nah, elektron valensinya itu apa, Mister? 4P2 kan, Mister?
It is in one.
Atau kita ambil yang 2 elektron, kan seharusnya elektron itu satu aja yang terakhir gitu, Mister. Nah, itu gimana, Mister, kalau ada 2 di akhir itu?
I didn't get your question. It is in one atoms, for example, 4s2, like this example, 3D10. I didn't get your question.
And then for V2.
For P,
2.
2. For this one, what is the valence electron, you mean, isn't it? Huh?
Yes, sir.
Yes, if it is like this, then the valence electron is in the shell, the last shell. So this one is the valence electron. 4. Okay? Because it is number 4, this is number 4. So 4 electron will be the valence electron.
Berarti 2 itu termasuk valence elektronnya, sir. Seharusnya kan 1 elektronnya terakhir atau gimana, sir?
No, valence electron is not the last electron. It's different. You confused about that.
Oh, okay, sir.
Valence electron is not last electron. No, it is not last electron. Different. It is the electron in the last shell. Last shell, bukan last electron. Jangan salah paham. So it's not this electron in the last. No. Maybe you confuse with last lesson. Last lesson I told you that generally when we are asking the quantum number is generally asking you the quantum number of the last electron. At that one, ya, kalau mau mencari quantum numbers itu biasanya kalau di pertanyaan yang nggak dikasih tahu, maka kalian berpikirnya elektron yang terakhir. But valence electron is not the last electron. Different. Valence elektron adalah elektron yang ada di shell terakhir, bukan elektron terakhir. Oke?
Oke, Mister. I know.
Okay. Any other question?
Mister,
Yes.
misal tadi kan berarti elektron valensinya ada 2.
Which one? This example?
Yang mana dulu, Mister?
Hah? You mean this example?
Misalnya ada ion misalnya ion positif. Terus ini elektron valensinya. Terus yang dikurangkan terlebih dahulu yang mana? Yang 4p2 atau 4s2?
For this one?
Yes.
You mean for this one? Generally for
Yes.
this one, if it is ending with P, it's difficult to lose electron. Generally, it's very difficult. Yeah. If ending with P, generally they will take electron. Jadi bukan menghilang mana duluan yang dihilangkan, tidak. Biasanya kalau yang seperti ini, it's difficult to lose electron. If ending with P, they generally they will take an electron. Okay. So your question is almost impossible. So that's why there is no rule for that one.
Oh iya, Mister.
Okay. If ending with P, they generally will take how many electron they will take, not how many electron that it will be losing. No. You will learn this one next topic. Yeah, why 4p is tends to take an electron, not losing the electron if ending with 4p. Ini pelajaran selanjutnya nanti ya, dipelajari. Kenapa kalau yang terakhirnya 4p itu dia lebih cenderungnya mengambil elektron, tidak melepaskan elektron. Any other question? We have 1 more minute.
Mister,
Yes.
misalkan elektron kita itu penuh deh, Mister. Penuh kan, P-nya penuh, D-nya penuh, S-nya penuh. Terus ada ion negatif. Nah, ion negatif itu kan artinya menambahkan. Terus kalau
Yes.
menambahkan itu, apakah kita harus menambahkan juga yang 5P misalkan?
Yes,
Harus menambahkan
sel. If it is possible, yes. But generally, if this is also the same answer like the previous question. If all of them full, yeah, if the configuration electron is full, all of them, then that element is stable. This element is stable. The stable element is generally difficult to become ion, either positive or negative. It will be difficult. Karena dia stabil, jadi nggak mau jadi ion, dia nggak mau jadi positif, nggak mau jadi negatif. Okay, it's also related with the next chapter. I have to finish the lesson up to here because we run out of time. Good luck for the midterm. Yeah, please study well. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
No post test today.
Thank you, Mister.
Thank you.